Dear students, today in this class we'll discuss about the chemical equilibrium. So equilibrium is a general term that is used in all the types of science, that is physics, chemistry as well as biology. So in the case of physics, what is equilibrium? When all the forces that are acting upon object are balanced. So that means when all the forces that are acting on a particular object are balanced, then the object is said to be in state of equilibrium. So equilibrium in terms of chemistry. So when the liquid evaporates in a closed vessel, what happens? The molecules which are having higher kinetic energy move from liquid surface to vapor phase. And again, since we are doing conducting in a closed vessel, what happens? The vapor molecules again strike back to the liquid surface. So that is giving rise to the constant vapor pressure, in which the number of molecules leaving the liquid to vapor equals the number of molecules returning into liquid state from vapor. So that means the number of liquid molecules that are converting into vapor state will be equal to the number of vapor molecules that are being converted into liquid state. So that is said to be in equilibrium state. So the mixture of reactants and products in the equilibrium state are called equilibrium mixture. So for example, if you take the H2O liquid is converted into H2O vapor. So that means that is R1. So what is R1? That is nothing but rate of evaporation. Through evaporation, the water which is in the liquid state will be converted into H2O, that is vapor state. But H2O vapor, when it is being converted to H2O liquid, that is known as R2, that is known as rate of condensation. So through condensation, the vapor state will be uh, converted back to liquid state. So what is happening at equilibrium state? At equilibrium state, R1 will always be equal to R2. That means the rate of evaporation will always be equal to the rate of condensation. So the equilibrium can be achieved in both the physical process as well as chemical process. Next, this equilibrium can be denoted by two half-headed arrows. So one half-headed arrow indicates forward reaction and the other half-headed arrow indicates backward reaction. This indicates that the process in both the directions are going on simultaneously. So equilibrium is applicable to many biological and non-biological processes. For example, equilibrium in the case of biological process, the maintenance of pH of blood. So in the case of pH of blood, the carbonic acid is converted into H plus ion and bicarbonate ion bicarbonate ion. So that is a biological process. In the case of non-biological process, the physical equilibrium, that is skating on ice, is an example for physical equilibrium. So the equilibrium can be applied for environmental processes. So yes, we can apply the equilibrium to the environmental process. So the toxicity of carbon monoxide with hemoglobin is due to the hemoglobin and carbon monoxide equilibrium. So, so this equilibrium, which is involving oxygen molecules and the hemoglobin, can be applicable in the transport or delivery of oxygen from our lungs to muscles. It can be done. So what is a dynamic equilibrium? So what is dynamic equilibrium? When the reactants in a closed vessel at a particular temperature react to give products, the concentration of reactants keeps on decreasing with increase in time and remains constant at a particular time. So when we are drawing a graph between the reactant concentration and the time, so the in the same way, the product's concentration keeps on increasing with time and remains constant after some time. After constant some time. So after some time, what is happening at a particular temperature? There is no change in the concentration of reactants or products. This stage of a reversible system is known as a dynamic equilibrium. So what is dynamic equilibrium? The equilibrium at which there is no change in the concentration of reactants or no change in the concentration of products. So based on the extent to which reacts the proceed to reach the state of equilibrium, it can be classified into three groups. So if you see the graph between concentration and time, so as the time progresses, see here, the reactant concentration continuously decreases and products concentration continuously increases. So this is the equilibrium state, see here, at which there will be no change in the concentration of reactants or products. So what observations can be drawn from the graph? The reactant concentration is very high at equilibrium and products concentration is very low at equilibrium. The reactions in which only small amount of products are formed and most of the reactants remain unchanged at equilibrium stage. So see here, reactant concentration is very low or negligible at equilibrium and products concentration is very high at equilibrium. So the reactants that proceed nearly to completion of the reactants or with negligible concentration of reactants are left at equilibrium state. The reactant concentration is very less or products concentration is very high. So see here, at the case of equilibrium, that at equilibrium stage, there is a measurable constant concentrations of both the products as well as reactants. So can equilibrium can be applied for ionic reaction. So this chemical equilibrium can also be applied for ionic reactions. So uh, if you see the examples for the physical process involving equilibrium, the phase transformation reactions. So what do you mean by phase transformation? That is nothing but change of state, change of physical state, that is from solid to liquid, liquid to gas, or solid to vapor. All these are phase transformation reactions. So what are the three states of matter that we observe in our daily life? Solid is converted into liquid, solid is converted into vapor, or liquid is converted into vapor, and so on. So, if we consider a particular example, solid ice, the ice which is in solid state is converted into water which is in liquid state. The following observations can be made. Masses of ice and water do not change with time. The temperature always remains constant, and equilibrium is not static. So an intense activity is noticed at the boundary between ice and water. So molecules that are present in the liquid water collide against ice and adhere. Adhere means stick to it, and some water molecules from ice at the same time pass into liquid phase, indicating the dynamic equilibrium. So there is no change in the mass of ice and water, as the rate of transfer of molecules from ice to water and reverse transfer from water to ice are equal at atmospheric pressure at a particular temperature, that is 273 Kelvin. So we can say that ice and water are equilibrium only at particular temperature and pressure. For any pure substance at atmospheric pressure, the temperature at which the solid and liquid phases are at equilibrium is known as normal melting point and a normal freezing point. That means the temperature at which the solid is converted into liquid state is known as melting point, and the temperature at which the liquid is converted into solid state is known as freezing point. So when we consider the dynamic equilibrium of ice and water, both opposing forces occur simultaneously, and both the process occur at the same rate, such that the mass of ice as well as water remains the same, and the liquid, vapor or gas equilibrium. So when we are considering the equilibrium between liquid and vapor, so what is happening in this case of liquid and vapor? So we can easily understand by considering a transparent box or jar carrying a U tube with mercury manometer. Mercury manometer. drying agent like anhydrous calcium chloride or phosphorus pentoxide is placed in a box for few hours, we have to remove the moisture which is present in the air. What happens? The mercury level in the manometer slowly rises and finally retains at a particular level constantly, which indicates that the pressure inside the box increases and reaches a constant value, and the volume of water in the dish gradually decreases. Initially, there is no vapor pressure due to water in the dish. However, with the passage of time, what happens? The evaporation starts and water molecule changes into vapor form and add to the pressure of air. That leads to the increase of mercury level. Increase of mercury level. So when we are considering H2O gives rise to liquid which is converting into vapor state, at equilibrium what is happening? R1 will equal to R2. The rate of evaporation will be equal to rate of condensation. Rate of condensation. So next, solid to vapor or equilibrium. Any substance which is exhibiting the sublimation property can exhibit solid vapor equilibrium. So what is a sublimation? So direct conversion of solid into vapor state without undergoing liquid state is known as sublimation. So see here, iodine solid is converted into iodine vapor at equilibrium. So purple or violet iodine vapor is converted into purple or violet iodine vapor. So this is a iodine solid which is converted into iodine vapor. So with this I will conclude the session. In the next class we will discuss about the remaining topics.